Okay, welcome to our I guess the third video on completing the square. So we're going to do some more examples. In this one, we're going to do a little bit trickier example, I guess. Looking at this example, if you've watched the other two videos, you might notice this example is a little bit more difficult because there's an a value. So remember, vertex form. We want to write this in vertex form, so we want to complete the square. In vertex form, looks like this. And in all the examples we'd done before, the a value had been 1. So when we made it a perfect square, we didn't have to worry about that a value. In this case, we're going to have to sort of deal with the a value first. So notice in vertex form, the a value is always factored out of the perfect square. So the a value doesn't go in the bracket. So we don't want this a value to be a part of the perfect square we make. So what we're going to do is just factor that 2 out. So if I factor 2 from 2x squared, I get x squared, plus, and if I factor 2 from 6, 6 divided by 2 is 3x. And now you might be saying, okay, do I have to factor the 2 from the 9, because that doesn't even go in evenly? Well, look at vertex form. Notice that the a value is only sort of factored from the perfect square. It's not factored from it doesn't multiply with the last number. So we're not going to factor it from the 9. We're just going to leave the negative 9 out there, just like the k was left out there. So we just factor it from the first two terms. And now we go about completing the square the way we did before. So you look inside the bracket, you leave these terms, and you say, okay, what do I need to do to this to make it a perfect square? So the sum should be 3. So what number multiplies with itself to get 3? Or what number adds with itself to get 3? So it's always half that number. So 3 over 2. But then the product of 3 over 2 times 3 over 2 would be 9 over 4. So it's always half this number, 3 over 2, squared, which is 9 over 4. So plus 9 over 4, but of course, you also have to subtract 9 over 4. And then there's still the negative 9. Notice both these terms go in the bracket. The first term definitely has to go in the bracket because it's part of the perfect square. And the second term also has to go in the bracket because remember that this must be 0. And if I put it outside the bracket, then I'd be multiplying one by 2, but not the other by 2, so it wouldn't sum to 0. So it has to go in the bracket. Although, we don't want it in the bracket, right? We want just the first 3 terms in the bracket, because then we could factor it as a perfect square. So what we're going to do is sort of take this last number outside the bracket. We want this out of the bracket. But you can't take it out of the bracket just arbitrarily. Notice that there's a 2 being multiplied by everything in the bracket. So if I want to take this last number outside the bracket, I kind of have to distribute the 2 into the bracket. But I'm only going to distribute to the last term because everything else I'm leaving in the bracket. So everything else is still multiplied by the 2 because everything else will stay in the bracket. 9 over 4. So that's the first 3 terms. And then the last term I want to multiply by 2. So it's 2 over 1. So 2 times negative 9, negative 18 over 4. And then subtract 9. So this last term came from 2 times minus 9 over 4. Now x. Now I can factor this as a perfect square. So remember, this term here is always half of this term. 3 over 2. 3 over 2 squared is 9 over 4, so that's good. Now we have to add these two together so we can get a perfect, or a common denominator. You might notice here, 18 over 4 is actually 9 over 2. Subtract, and then I want this to be over 2 also. So I multiply 9 times 2 and I get 18. Y equals that'd be minus 27 over 2. So vertex form. We're good. We wrote it in vertex form. Okay, so that's the process of completing the square, and that's kind of the full process where you have an a value of not 1. So if you wanted to write sort of the steps, I usually write it as 4 steps. First step is to factor a, so a is the number in front, from first 2 terms. First 2 terms. So you only factor from the first 2, not from the third one. One thing just mentioning when that was this step here. This is step 1. So notice you factor 2 from the first 2 terms. Some people will object and say, well, why aren't you factoring an x? Because there's an x common, so I could actually common factor 2x. And if you were fully factoring, yes, you would do that, but we're only factoring the a because we want to do something specific. We want to make it look like in vertex form. So we need the x squared and the x term there. So we don't factor the x, even though you could, but then it wouldn't look like we wanted to. Okay, so that was step 1. Step 2, you add and subtract the number that makes it a perfect square. Well, what number always makes it a perfect square? Remember, the first thing you do is you take sort of the b value, b, and you divide it by 2. That would give you 3 over 2, and then you square that number. So b over 2 squared, right? In this case it was 3 over 2 squared. 3 over 2 squared is 9 over 4. So that's step 2. Step 3 was this step here, where you remove the last term in the bracket, so the 4th term in the bracket, from the bracket by multiplying a. So multiply last term in bracket by a to remove from bracket. Okay, so that was this step. We multiplied 2 times the last number to get us out of the bracket, and then sort of the final step, although we did this in sort of 2 different steps. There's 2 things going on in the final step. One, you have to factor the perfect square. So factor perfect square. And the second thing you have to do is, just looking at what we did, I did this in a second step, but really it's the same thing. You could do it all at once. Add the terms outside the bracket. So factor the perfect square and add, or subtract if it's subtraction, and add terms outside the bracket. Okay, so those are your, can I get it all in one? No. So first, factor a, so that's the coefficient a from the first 2 terms. Then you add and subtract b over 2 squared. Then you multiply the last term in the bracket by a. Again, that's the coefficient a to remove from bracket. And then you will have a perfect square, which you factor, and you add the outside terms in the bracket. And you will have it in vertex form. So that's the process.